All right, so now let's check out C. So C, let me just go back up here. C, you take x plus 5y, it's less than 15. This is your x, this is your y, so I plug in 1 plus 5 times 3. 5 times 3 is 15, and 1 plus 15 is 16. And I ask myself, is 16 less than 15? Is the alligator eating the bigger number? No! So this is not a solution. Just to make sure, let's go ahead and check this one out real quick. X is 2, y, y, sorry, I flipped that. X is 3, y is 2. Sorry, I'm making sure that it is. I was like, what am I doing? Okay. 5. Okay. 5 times 2 is 10. 13 plus 10 is 13. And that is a true statement. So that one's out. So it is C. All right, so we have to start by making a graph from this. So remember, we always, when we're graphing, we think about y equals mx plus b. So we start with the y-intercept, which in this case is -1. Now I need to worry about the slope. So you can pick any 2 points. I'm going to pick this point right here. Doesn't really matter. You could have picked any point on there. Remember, slope is rise over run. Before I even get going, I'm going downhill, so I definitely know this is going to be negative. I go down 2 over 2. -2 divided by 2 is -1. So that's going to be a negative x. And then I got to look at my inequality. All of my values are becoming smaller. They are less than. So they are less than. It's a solid line, so equal to. Same thing. I start with y equals mx plus b. And I start out with the y-intercept, which is, once again, -1, -1. Go ahead. Now we got to worry about slope. Rise over run. I'm going up the hill, so it's, oh my goodness, it's so pretty. It's positive. I'm going to use this one. I don't know. So I go up 2 over 2. 2 over 2 is 1, so it's just x. And then all of my values are going down. So once again, this is less than or equal to, because it's a solid line. All right, can you use 0, 0 as a test point? First of all, we have to graph, we have to put it in y equals mx plus b. So we have to do a little bit of something over here. We want the y on the left, so I could actually start by just flipping this, making this -5y over here, 2x over here. It's eating the 2x, so it needs to eat the 2x. I get y by dividing by -5. When I divide by the negative, I flip. 2 divided by -5 is just -2/5, and then x. Remember, if it makes you feel better, you can put that +0 there. So if I graph it, my y-intercept is 0. My slope is -2/5, so I go down 2 over 5. 1, 2, 3, 4, 5. Up 2 over 5. It doesn't have that equal sign under there, so it's going to be dashed. And then now I got to worry about my testing, and this is what it's talking about. Can you use 0, 0 as a test point? You may not, because, it's actually a little off. Let's go like that. You may not, because it's already on the line. You cannot use it if it's on the line. So no. You're going to have to, this is one of the cases where you would have to use like 1, 1 to determine how to shade. So let's just go ahead and do it. 1, 1. So 1 is greater than -2/5 times 1, which is just -2/5. That is a true statement. So since it's true, I want to shade where that point is. So I would I would shade above. So once again, no, you cannot use that as a test point, the origin. All right, determine whether the ordered pair is a solution. So this is like what we were just doing for a couple ones ago. So this is your x value, so x is equal to 2, and this is your y value, so y equals -1. All I'm doing is plugging and making sure that the inequality is true. So 3 times x is equal to 2 minus y is negative 1 is less than 10. So let's do some order of ops. 3 times 2 is 6. I'm going to go ahead and make 2 negatives as a positive. 6 plus 1 is 7. Now, the alligator wants to eat the bigger number. So 7 is less than 10. This is true. So since that is true, yes is a solution. Here, this is x, y. So x is equal to negative 3. Y is equal to negative 4. So now I plug in. So I use my original inequality. Y is negative 4. X is negative 3. Order of ops. 2 times negative 3 is negative 6. Negative 4 minus 6 is negative 10. Then I ask myself, is that greater? Would I rather be down $10 than $5? No. Not a solution. Jake's allowance for the month is $90. He wants to go buy a skateboard for that cost, or for the cost, $55. Inequality. Write and solve an inequality that shows how much money he can spend that month, including the purchase of the skateboard. All right, so he's got $90. Okay, $90. He wants to go and buy, so he has $90. That's the most that he can spend. Okay, that's all he's got. He can't spend any more than $90. So if you're thinking about your inequality, 90 has to be greater than or equal to, because he can't go past $90. Okay, then he wants to buy a skateboard for $55. Okay, so, all right, $55. And then whatever's left over is left over. So then now it says solve the inequality that shows how much money he can spend that month, including the purchase of the skateboard. All right, so all we'd have to do is just subtract 55. Those would cancel. 90 minus 55 is 35. And then just for good measure, I'm going to go ahead and flip it. All right. All right, so we're going to go ahead and graph. This is luckily for us already in y equals mx plus b. So I go to my y-intercept, which is a positive 3. Put my point. My slope is 2 over 1, so I go up 2 over 1. Then I do the opposite, down 2, left 1. I look at the inequality. It doesn't have that equal sign under there. Therefore, it's automatically going to be a dashed line. And then we have to decide about our shading. Okay, so we're going to use the test point 0, 0. So 0 is greater than 3. That is false. So since that's false, I have to go the opposite way. So I'm going to highlight the opposite way. And I'm going to get as close to the line. I got a little sloppy right there. As close to the line without going over. All right, I have to convert it into y equals mx plus b. I start by subtracting 3x. Divide everything by negative 2. When I divide by a negative, I flip. Okay. Negative 3 divided by negative 2 is just 3 halves x. A positive 12 divided by a negative 2 is a negative 6. Now we can go ahead and graph. My y-intercept is negative 6, so 1, 2, 3, 4, 5, 6. My slope is 3 halves, so I rise 3, 1, 2, 3, over 2. I need 3 points, so I'm going to rise another 3, go over 2. The inequality does not have that equal sign under there, so it needs to be dashed. And then now I take my test point 0, 0. And honestly, you could plug it into this equation. You can plug it into the original. It's up to you. 0 is greater than negative 6. Or if you plugged it in here, this would be 0 minus 0. So 0 is less than 12. Either one, they are both true. This is true. This is also true. So I need to include that dot. So I need to make sure I highlight the section with that point. All right, so this one's a system, so you should have two different markers out. Let's start with y is less than 6. So y, I go to the y-axis. You can think about hoi vux. Vux. This is an H, so it's going to be a horizontal line. So I go to the y-axis to a positive 6. 1, 2, 3, 4, 5, 6. Horizontal, so side to side. Once again, it doesn't have that equal sign under there, so it's going to be dashed. I use the point 0, 0 as my test. So is 0 less than 6? That's true. I'll go ahead and just use purple since I used purple. All right, this entire graph. It's a lot of highlighting. Okay, so now that I just used purple, I'm going to make sure I have yellow on my next one. I'm just saying. All right, this one's already in y equals mx plus b for us, so I go to positive 3. And then up 1 over 1, because this is 1 over 1, down 1. It also does not have an equal sign under it, so it's dashed. And then once again, I can use this point 0, 0. So I'm just going to take it over here for a second. So 0 is greater than 3. That is false. So I have to go the opposite way, which would mean I need to go this way. And I'm highlighting yellow, but it's turning red. So my solution to this graph is the red and the red only. And remember, I like for you to go back, make sure that you define that these are both dashed lines. All right, so this one's a big one. Solve the system of inequalities by graphing. All right, so let's start with just go ahead and doing it. So we start over here and we subtract x to both sides. So the first equation or inequality is going to be y is greater than negative x minus 2. Over here on the second one, we subtract 2x on both sides. Therefore, that one's y is less than or equal to negative 2x plus 1. Now I can graph. All right, so I go to the first one. My y-intercept is negative 2. My slope is negative 1, so I drop 1 over 1, up 1 over 1. It does not have a equal sign under there, so it's dashed. I use my test point 0, 0. So 0 is greater than negative 2. That is true. So I highlight above because that's where that point is located. Okay. Now I'm going to do the other one. Let's do an orange. Okay. So I go to positive 1 because that's the y-intercept. My slope is negative 2 over 1, so I drop 2 over 1, up 2 over 1. This is it's got that equal sign under there, so this time it's solid. Grab my highlighter, and I test the point 0, 0. So is 0 less than or equal to 1? That is true. So I need to highlight down below. Now while I'm finishing this, we're going to go through each answer on the next video. So if you need to know the answers, go to the next video.